Hi students, welcome to the science class. In last session, under the chapter of atoms and molecules, we discussed about the properties of the atoms and the molecules. And also in last chapter, one of the scientists said that the name of the scientist is Dalton. He said that the materials or the elements are made by the small subatomic particles, some small particles that are called as atoms. Atoms are the basic particles of an element that cannot be divided. He said that the atoms are the smallest particles of an element or any particle, so these cannot be divided, he said. And on the basis of the atom, so in that days, that is at the 19th century, the other scientists are going to be started the research about the atoms. So when we are going to say an element or any material that can be made by the small particles called the atoms, then what is the structure of the atom, what are the properties of the atom, and all the elements are made by the smallest particles called atoms, but what are the different properties makes the atoms, every different atoms of the different elements shows the different characters, isn't it? For example, I am taking the hydrogen atom here. Hydrogen atom shows the different character, and oxygen atom shows the different characters. It possesses the different characters, and oxygen atom also possesses the different characters. Then what property of that atom is the reason for to shows the different characters here? Because the oxygen atom, it is also a smallest particle of that element. It is also not divided according to the Dalton theory. And the hydrogen atom, it is the smallest particle, and it can also not be further divided. And but these are the atoms, these are the smallest particles of that element, but they possesses different characteristics. And so on this basic property, at the 19th century, the scientists present at the 19th century, they are starting their works to find out the structure of the atom. If we are going to say the atom, it is a basic property, it is a smallest unit of any element, then what is the structure of this element, what is the structure of that element, atom, and what that atom consists of, that can be studied by the scientists which are present in the 19th century. So afterwards, the scientists are going to research about the atoms. One of the scientists at that time, that is J.J. Thomson, he used to make the research on the atoms to study about the structure of the atom. How is the structure of the atom is present? Is there any other subatomic particles are present in the atom or not? Why? Because the Dalton already says that the atom, it is the smallest particle of an element. It cannot be subdivided again. It is the smallest, it is the end of the element. We can't divide an atom. He said that, Dalton said that word. But the Thomson makes a study on the atoms, and he concluded that atom, it is not a final substance or a final material. It is not a basic element of the any element. We can also divide atom, and also atom has a subatomic particles. How he is going to say? Why? Because he may make an experiment. According to the cathode ray experiment, he concluded that atoms have other subatomic particles. Why? Because based on the cathode ray experiment, he observed that in the cathode rays, some of the radiations comes along with the cathode rays. According to this, that J.J. Thomson considered that the atoms are also has subatomic particles. See, the J.J. Thomson proposed the atomic theory. He explained about the presence of the electrons in an atom by the cathode ray experiment. He conducted an experiment. According to that experiment, basis of that experiment, he says that the atomic theory explained about the presence of the electrons in an atom. According to that cathode ray experiment, he says the presence of the electrons in an atom. So what happens here? This says that the Dalton theory is here fails. Why? Because Dalton says that the atoms are the smallest final undividable particles present in an element, but here in the atoms he says that the subatomic particles, electrons are present, he said. So in this model of the atom, it is called it as a watermelon model. He called his model as a watermelon model. Why? Because according to him, an atom it is just looks like a watermelon. So why he is called it as a watermelon? See now, in this model, Thomson predicted the presence of the electrons in the positive space just seen as the seeds of a watermelon are embedded in it in a red edible part. See here, according to him, atom is just look like a, according to him, atom is just look like a cut part of an watermelon. And he says that the positive sphere it is, a atom consists of a positively charged sphere and electrons are embedded in it. He says that the positive sphere is present at the outer surface, that is the white surface which we are going to see in the watermelon when we are going to cut the watermelon into two pieces. So the white space which we are going to see, in that like atoms consist a positive sphere. And he says that electrons are present inside the positive sphere. Electrons are present inside the positive sphere in the edible part. In the watermelon, which part is edible? The red part, isn't it? We are going to eat the red part of the watermelon. So in that edible part, we are going to see the black color seeds are present. So like that, in the red colored area or the edible part in the watermelon, the seeds are present. Like that, in an atom, the electrons are present inside the positive sphere. He says that he compared the atomic model with the cut part of the watermelon. The J.J. Thomson, he explains the structure of the atom based on his experiment, that is cathode ray experiment. He says that the atom consists of a positively charged sphere, all the positively charged sphere, and all the electrons are present inside the positively charged sphere. So how they are present? Just like the seeds are present inside the watermelon. And he says that the positive and negative charges are equal in magnitude, so that atom is electrically neutral. So he says that the number of positive charges and the number of negative charges present in an atom, they are equal, and therefore an atom is electrically neutral. So basis on his study, he explained the structure of an atom basis on his experiment, that is cathode ray experiment. He says two postulates here. You have to remember the structure of the atom, it is not comes quickly. The structure of the atom will be confirmly we got from number of studies, but we are going to study now how the structure will becomes, how the study of that structure will be started now. First, the study of the structure started with the Thomson model or the Thomson experiment. He says some of the postulates, he assumed that he couldn't see that atom exactly, but he assumes that the positively charged sphere is present in an atom, and inside that positively charged sphere the electrons are present. So he said that two postulates, an atom consists of positively charged sphere and electrons are embedded in it. The positive and negatively charges are equal in magnitude, so that the atom is electrically neutral. But he assumed the assumption of the Thomson or the structure of the Thomson fails to explain the other characters of the atom, which comes from another scientist who did the experiment to find out the structure of the atom. So in that case, another one scientist will come here, that the name of that scientist is nothing but the Rutherford. Rutherford started his experiment to study the structure of the atom. Why? Because it is a basic need in that time. It is about the 19th century. In the 80th century, Dalton proposes that elements are made by the atom. So if the atoms are present in an element, then what are the structure of that element and what are the properties of that atom, that can be needed, that study can be needed in that time. So therefore, the another one scientist, Rutherford, started his experiments to study about the structure of the atom, and he proposed an atomic model here. So basis on his experiment, he conducted an experiment to know the presence of the electrons in an atom. So first, the J.J. Thomson says that the electrons are present in an atom. Before that, we don't know what are present in the atom. So according to the Dalton theory, the atom is a final point, that is, it is the smallest unit. This unit can't be divided by us, but by the Thomson, we are going to know that scientists, that they are going to know the atoms are also consist subatomic particles. The one of the subatomic particle, it is nothing but electron. Based on his study, the Rutherford conducted an experiment to know the presence of the electrons in an atom. So what he did in his experiment, we see now. In this experiment, he made to fall alpha rays on the thin gold foil, but he observed 3 reacts. So what is the experiment done by the Rutherford atomic model, or Rutherford here? So you are already studied this experiment in 8th class. What he did, I just remembering you. He taken a thin gold foil and he tried to, in this experiment, he made to fall alpha rays on a thin gold foil. He made 2 foil, just see here, this is the gold foil. He made to fall alpha ray particles on the gold foil. So in that experiment, he can observe 3 reactions here. He observed 3 observations. He clearly seen here that are, first one, it is most of the particles are passed through the gold foil undefectedly. So when he started his experiment to make fall the alpha particles on the gold foil, he started to float the alpha particles on the gold foil. Some of the alpha particles are passed from, most of the alpha particles are passed through the gold foil undefectedly. Most of the alpha particles are passed here. The alpha rays are passed undefectedly. They are not they shows any deflections here. And second observation here, we have to clearly see the observations done by the scientist. So in what way they are thinking, so you can remember, you have to know here how the scientists are going to be think. Most of the particles passed through gold foil and undefectedly. They are not shows any deflection. They pass through the gold foil, the alpha particles. But some of the alpha particles deflected by the small angles. Some of the alpha particles, I show here only 2 alpha particles. Some of the alpha particles have some deflections. When they made to fall on a gold foil, only few particles have a deflection here. And third observation is 1 out of every 12,000 particles, 1 out of every 12,000 particles appear to be rebound. 1 out of every 12,000 particles, if you are going to made to fall at 12,000 alpha particles on a gold foil, only 1 alpha particle will be rebound. And in that, what happens here, many alpha particles are passed through the gold foil without deflection, and only few alpha particles shows deflection, but only 1 out of the 12,000 alpha particles will be rebound. Basis on these 3 observations, he make conclusions here. He come to know the conclusion. What are the reason behind it? When we are going to make the alpha particles fall on the gold foil, only 1 alpha particle about in the 12,000 will be rebound, and many alpha particles are passed through the gold foil, and only few alpha particles shows the deflection here. So why they shows the deflection? Why many alpha particles are passed through the gold foil and only few alpha particles shows the deflection? That he comes to know the conclusion for that questions. That is, An atom consists of a predominantly empty space. So from these three observations, he come to the conclusion that an atom consists of predominantly empty space, as most of the alpha particles are passed through the gold foil. See here, so from this experiment he come to know the conclusion that most of the atom consists of the free space. Most of the atom consists of the free space. That's why the most of the alpha particles are passed through the gold foil. So atom consists of a predominantly empty space, and as most of the alpha particles are passed through the gold foil. And second observation here, second conclusion here, atoms contain centrally placed positively charged nucleus. Based on these three observations, he concluded that atoms contain centrally placed, atom contains centrally placed positively charged nucleus, because alpha particles suffered reflection and they are very few. So the atom consists of a small nucleus at the center. Why? Because only few, it means only 1 out of 12,000 alpha particles will reflected, that is rebound here. And third observation, that is third conclusion, since the minute fractions of the alpha particles are suffered deflections here, since the minute alpha particles shows the deflections here, and these observation leads to the conclusion that the most of the space in an atom is empty and the space occupied by the nucleus is negligible compared to the empty space. On the basis of three observation, he come to the conclusion that most of the space present in an atom, it is empty. Most of the space present in an atom, it is empty, and a very small nucleus is present. Why? Because why he is going to say that the nucleus is very small, because only 1 out of 12,000 alpha particles will rebound here. Only one alpha particle rebound about in the 12,000 alpha particle. That shows the nucleus is very small here, isn't it? And also only some of the alpha particle, only few alpha particles are shows reflection. That says that only some few electrons are present in the atom. So basis on this conclusion and the observation, he come to explain the postulates of the Rutherford atomic theory. His atomic theory comes to know the characteristics of the atomic theory. From the observations and conclusions by the Rutherford, he comes to explain the postulates of his atomic model. And the Rutherford atomic model, it is also called it as a nuclear model. Why? Because the first scientist who says the presence of the nucleus in an atom, that is who is nothing but the Rutherford here. Therefore Rutherford atomic model, it is also called it as a nuclear atomic model. So what are the postulates of the nuclear atomic model? What are the postulates he says? See now, the positively charged particles held together in the center of the atom, and it is called it as a nucleus. By the observations and the conclusions, he says some postulates here. He come to explain the postulates of the atomic theory. That is, first postulate is here, the positively charged particles held together in the center of the atom, and it is called it as the nucleus. He says that the center of the atom, the positively charged particles are present at the center of the atom, and that is called it as a nucleus. And second, it is electrons are revolving around the nucleus. It says that electrons are revolving around the nucleus, and size of the nucleus is very small compared to the size of the atom. And third postulate is size of the nucleus is very small compared to the size of the atom. Why? Because he observed only few alpha particles are comes back, few alpha particles are reflected back, about only one alpha particle about in the 12,000 alpha particles will be comes back. Therefore he says that size of the nucleus is very small compared to the size of the atom. So these are the postulates are said by the one of the important scientists here, that is Rutherford. That is these are the postulates of the Rutherford atomic model, that is nuclear atomic model. In your examination, these can be asked for 2 to 3 marks question. Write down the experimental setup, observations, conclusion, and the postulates of the Rutherford atomic theory or nuclear atomic theory. So, but from the other experiments done by the other scientists, some of the drawbacks are going to be found here. Why? Because the theory of the Rutherford about the atomic theory or about the structure of the atom not holds good here. Why? Because some of the drawbacks are present in his theory. What are the drawbacks? Drawbacks of the atomic theory. He explained that outermost electrons lose their energy. See what say here? He says that the electrons are revolving around the nucleus. In his atomic model, he says that the electrons are revolving around the nucleus, and the outermost electrons, he says that outermost electrons loses their energy and fall into the nucleus. He says that outermost electrons loses their energy as they are moving continuously and they fall into the nucleus. But if this happens, if the electrons are going to be but this makes atoms highly unstable here. If the electrons are going to be fall into the nucleus, if they are going to lose their energy, if they are going to fall into the nucleus, then that condition makes atoms becomes not stable. Why? Because the electrons are revolving in their own path. If they are going to lose their energy and fallen into the nucleus, then the atoms doesn't stable in that condition. But we already know that atoms are highly stable. So this theory this statement it is one of the drawback, that is one of the drawback of the Rutherford atomic model. So to correct this drawback, the underwent scientist called it as Niels Bohr, he started the study about the structure of the atom, and finally he explained the atomic structure definitely. And nowadays we are going to study the atomic structure based on the Bohr model of the atom. That is the model of the atom, it is called it as a Bohr model. The Bohr, it is the name of the scientist, that is Niels Bohr. He corrected the drawbacks of the Rutherford atomic theory and he makes his own postulates. He explained the structure of the atom, the postulates of the Niels Bohr atomic model here. So he explained the structure of the atom. Electrons are revolving around the nucleus only in the certain permissible circular path called orbit. So what Rutherford says the electrons are revolving around the nucleus. He only says the electrons are revolving around the nucleus, but he doesn't say in what way, in which path. He doesn't say about anything. But the Niels Bohr says that electrons are revolving around the nucleus only in the certain permissible circular path, only in the certain permissible circular path, and they are called it as a orbit. He says that the electrons are revolving around the nucleus in a certain circular path, If you are going to imagine that this is an structure of the atom, this is the nucleus. If it is a nucleus, the electrons are revolving around the nucleus in a certain permissible circular path, and these circular paths are called as orbits. These circular paths are called as orbits. The shells are named as K shell, L shell. The number of the shells and the number of the orbits are named as from the nucleus. The first orbit, it is named as K shell. First orbit, it is named as K shell. Second orbit, it is named as L shell. Third orbit, it is named as M shell, and fourth orbit, it is named as N shell, so on. So the circular paths are named it as orbits, and we are going to name that. He named that orbits as a K, L, M, N, and so on from the nucleus. And these shells contain he says that these shells contain a definite number of electrons. These shells contain a definite number of electrons. He says that the each cell contain 2n square number of electrons. Each cells contain 2n square number of electrons. For example, K it is a first cell. K it is a first cell. K contains 2n square number. So we have to put here K is a first cell. Therefore 2n square. 2 into 1. 1 because this is the first cell. 2 into 1 square. 1 square it is nothing but 1. 2 into 1 it is 2. The K shell, the capacity of the K shell is 2 electrons. 2 electrons. And L shell, L is a second cell, so L also has a 2n square number of electrons. The capacity of the L cell is 2n square, that is 2 into n here, the L number, the number of term, that is it is the second shell, subshell or the second orbit of the atom. Therefore 2 into n square, and it is 2 here, 2 into 2 square, that is 2 into 4, that is 8. Therefore the capacity of the L is 8. L, this orbit L has 8 electrons. And third one, the third subshell, that is it is nothing but the M. So the capacity of the number of electrons are present in the M shell, it is 2n square, and n, the n is equal to 3 here. Why? Because it is the third orbit. Therefore 2 into 3, 2 into 3 square, 3 square it is 9, 2 into 9 is equal to 18. Therefore the capacity of the M shell, M orbit, it is 18 electrons. And nth shell, the number of electrons are present in the n shell, it is 2 into 4 square because it is the fourth orbit. 2 into 4 square it is 16. 2 into 16 it is equal to 32. The capacity of the n orbit, it is 32 electrons. Like that, each subshell has the definite number of electrons, that is the 2n square number of the electrons. That is the second postulate of his theory. And next he says that electrons in each shell have associated with a definite amount of energy. That is, electrons in a higher shell have the more energy than the electrons present in the lower shells. So he says that electrons which are present in the each shell has a associated with a definite amount of energy, has a definite amount of energy. And the electrons which are present in the higher level subshells, the electrons which are present in the higher shells has the high amount of energy than the electrons which are present in the lower shells. And the next postulate of this atomic theory, it is the energy of an electron remains constant as it revolves in the own shells. So he is corrected the drawback of the Rutherford theory here. What Rutherford says? Rutherford says the electrons loses their energy and finally fall into the nucleus, but the Niels Bohr says that the electrons doesn't lose their energy if until they move in their own subshells or own their orbits. If an electron continuously moving in its own orbit, then it doesn't lose any energy. That is, the energy of an electron remains constant as it revolves in own shell. These shells are represented by energy levels. Why? Because it is represented by energy levels, because the electrons until the electrons doesn't go away from these orbits, the energy of the electrons doesn't changes. The energy of the electrons remains constant. Therefore the each shells are again renamed as energy levels. Why? Because electrons doesn't lose energy. Therefore there is no change in the energy of the orbits of the atom. Therefore that shells are again renamed as energy level. So K energy, it is we can consider as first energy level. K subshell is the first energy level, and L subshell is the second energy level, M subshell is the third energy level, N subshell is the fourth energy level, like that. Why? Because the energy of the orbit remains constant. So Based on this, how we are going to represent the electrons? So we know that now the electrons are present in a definite number in the definite orbit, isn't it? But how the electrons present, how we are going to represent the electrons, now we are going to see here. See here, it is the most important part of this chapter. You have to clearly observe here. I am considering one example here. If oxygen, the atomic number of the oxygen is 8, therefore it has 8 electrons. How we are going to represent the electrons in the atomic model or atoms? I am considering this is the nucleus, isn't it? This is the first shell, first orbit, second orbit, third orbit, fourth orbit. That is K, L, M, N. You can write here K, L, M and N. The atomic number of the oxygen is 8. The number of electrons present here is 8. We have to fill the electrons from the first shell. The capacity of the first shell, that is K is equal to 2n square, that is 2 into 1 square, that is equal to 2. So we have to fill the electrons in the first orbit. The capacity of the K shell is 2. Therefore, 2 electrons are filled here. The first orbit fulfill here. The remaining electrons present in the oxygen atom, that is nothing but remaining 6. We have to fill the remaining atoms in the next orbit. So, the capacity of the L orbit, 2n square, that is 2 into 2 square, because it is the second orbit. 2 into 4, that is equal to 8. But we have only here remaining 6 electrons. So the 6 electrons are going to represented in the L orbit. So this is the representation of the electrons present in an atom. Oxygen atom has 8 electrons. Therefore, the first 2 electrons will fulfill the K subshell. Why? Because why we are going to place only 2 electrons in the K shell? Because the capacity of the K shell is 2 only. Therefore, we fill only 2 electrons. And in the capacity of the L shell, it is 8. But we have remaining only 6 electrons. Therefore, we are going to represent the 6 electrons in the L shell. I am considering another one example here. That is, I am taking the neon with the atomic number 10. Neon with the atomic number 10. Atomic number 10, that it has 10 electrons. It has 10 electrons. I am representing in the same atomic structure here. See, first subshell. First is K. The capacity of that K is 2. So we are going to fill the electrons, 2 electrons. One is here and second one is here. Then we are going to represent in the electrons in this next orbit, that is L subshell. The capacity of the L is 8. So remaining electrons we have the remaining 8 electrons. So we are going to represent remaining 8 electrons in the L subshell. 1, 2, 3, 4, 5, 6, 7, 8. See, so the L subshell is also fulfilled here. So we are going to represent the electrons based on the capacity of their orbit here. This is the representation of the electrons, isn't it? We have to fill the electrons after completely fulfilling the one orbit according to their capacity. So now we know how we are going to represent the electrons in the atom, the number of electrons present in the atom, how we are going to represent the electrons in the orbit of an atom. So now I am considering atomic number. What is atomic number? I am considering the last exam, the atomic number of the oxygen, it is 8. The 8 represents the number of electrons and the protons. The number of electrons and the protons are always equal. The number of electrons present in the atom, it is always equal to the number of electrons present in the atom. So therefore, I am says that is the atomic number of the oxygen is 8. What it represent? What is atomic number? The atomic number, it is nothing but the number of protons present in the nucleus is known as the atomic number. The number of electrons or a number of protons, the number of protons present in the nucleus, that is known as the atomic number, and also it represents the number of electrons present in an atom. Why? Because atom always has a equal number of protons and equal number of electrons. So therefore atomic number, the atomic number, it is nothing but the number of protons present in the nucleus. It is known as atomic number. So and it is represented by a Z. Generally we are going to represent an element, we are going to represent any element like ZXA. The X represent the symbol of that element, and the Z represents the atomic number and A represents its mass number. So therefore what is atomic number here? The number of protons present in the nucleus of the atom, that is known as the atomic number. For example, I am taking hydrogen with the atomic number 1. So what it represents? The hydrogen atom has 1 proton and 1 electron. So this is about atomic number. Next it is mass number. I says that A represents the mass number. What is mass number? The total number of protons and neutrons present in the nucleus. The total number of protons and neutrons present in the nucleus, that is known as the mass number, and it is represented by the letter A. So the X is the symbol of the element, that is here I am taking H, it is hydrogen, the symbol of the hydrogen, that is H. So 1H1, that this one represents the atomic number and this one represents the mass number. So what is mass number? The total number of protons and neutrons present in the nucleus of the atom, that is known as the mass number, and it is denoted by the letter A. So then we are going to know what is meant by the isotopes. The main important concept here, isotopes. The atoms which has the same number of protons but differ in their mass number. The atoms which has same number of protons but differ in their mass number. If the atoms has the same number of protons, that means the atoms which has the same atomic number and differ in their mass number, that is known as the isotopes. The atoms which has the same number of protons but differ in their mass number, that are called as isotopes. For example, hydrogen has with atomic number 1 and it has atomic mass 1. But deuterium, it is also a hydrogen molecule. So atomic number of the deuterium, it is 1, but the atomic mass, that is mass number of the hydrogen, that is it is 2. So here the atoms which has the same number of protons, the atomic mass, that is the atomic number of the both the elements is the same here. The number of protons present in the both the elements, it is 1, but differ in their mass number. These are known as the isotopes. For example, hydrogen, deuterium, tritium. This is one of the example for isotopes. And another one important concept here, isobars. What are isobars? Atoms of the different elements with a different atomic number and have the same mass number. So in the case of the isotopes, they have the same atomic number but differ in their mass number. In the isobars, atoms of the different elements, here the atoms of the same elements we are going to take. Isotopes are the atoms of the same elements, but the isobars are the atoms of the different elements have the same number of, has the same mass number but differ in their atomic number. That elements that are called it as isobars. So what is isobars? Atoms of the different elements with a different atomic number and have the same mass number are called it as isobars. For example, sodium with the atomic number 11, it has the mass number 24, and magnesium with the atomic number 12, it has the mass number 24. So isobars are the two different elements. Atoms of the two different elements has the same mass number but differ in their atomic number. These elements are called it as isobars. So these are the very important concepts which are comes under the chapter of the structure of the atom, and this completes your one of the most important chapter for your examination and your future studies, that is nothing but structure of the atom. In next session we are going to continue your another one new lesson. Thank you.